Hello my dear friends, welcome to my YouTube channel. Myself, Dattu Patel, Assistant Professor from LJIT. Today's session, we are going to discuss about the gradient and directional derivative. Let's see, firstly, gradient. The gradient of any three variable of the scalar function f of xyz can be denoted by grad f or nibla f, and it is defined as grad f equal to nibla f equal to I cap del f by del x plus j cap del f by del y plus k cap del f by del z, where grad f is a vector function. Here our question which is in form of scalar function and answer we get in form of vector function, that is it is nothing but the scalar quantity to vector quantity conversion. Here I cap, j cap and k cap, that is indicate by the directional of the x axis, y axis and z axis. That means I, j and k cap, that is a direction component. To find the gradient of a curve, you must draw an accurate sketch of the curve at the point where you need to know the gradient and draw a tangent of the curve. A tangent is a straight line which touches to the curve at one point only. Then you can find gradient of this tangent. Let's see one example of the finding the gradient of the tangent to the curve y equal to x square at the point 39. In this graphical representation, the curve y equal to x square, that is the shape of parabola. Now substituting the x equal to 1, 2, 3, 4 and so on, then we get the values of y. Means whenever x equal to 1, then y equal to 1, x equal to 2, then y equal to 4, x equal to 3, then y equal to 9 and so on, and we get exactly this type of shape. Here we have to find at point 39, then red line indicate by the tangent, then here one point which is 39 and other point we have to consider 2.3, 5, then gradient of the tangent equal to change in y coordinate upon change in x coordinate. Here y coordinate, that is 9 minus 5 divided by 3 minus 2.3, that is x coordinate, then we get 5.71. In this method we can only give an approximate answer. The better your graph is, the closer your answer will be correct answer. If your graph is perfect, then answer of this sum would be 6. Let's see parallel lines and perpendicular lines. In this graphical representation, two lines are parallel if they have the same gradient. Similarly, for the perpendicular lines, two lines are perpendicular if one is at right angles to the another. In other words, if the two lines cross and angles between the lines is 90 degree. If two lines are perpendicular, then their gradients will be multiplied together to give -1. Let's see one example. Find the grad f or a nibla f at point 1, -2 and 1. If function is equal to 3x square y minus y cube z cube. Firstly, whatever the function which is f of xyz equal to 3x square y minus y cube z square. Now partial derivative of the function with respect to x, with respect to y and with respect to z, that will give you fx equal to 6xy, f of y equal to 3x square minus 3y square z square, and f of z equal to minus 2y cube z. Now we have to find the grad f or a nibla f, that is our gradient, equal to I cap del f by del x plus j cap del f by del y plus k cap del f by del z. Now substituting the values of fx, fy and fz in this equation, and we get I cap 6xy plus j cap 3x square minus 3y square z square plus k cap minus 2y cube into z. Now we have to find at point 1, minus 1 and 1. Then substituting x as a 1, y as a minus 2 and z as a 1 in this equation and simplified it. Then we get nibla f equal to I cap minus 12 plus j cap 3 minus 12 plus k cap 16. Then nibla f equal to, that is our gradient, minus 12i minus 9j plus 16k. Here that is our vector quantity where I, j and k indicate by the direction of the x axis, y axis and z axis, that is the direction component. Let's see one more example. Prove that nibla r raised to n equal to n into r raised to n minus 1 into r bar, where r bar equal to xi plus yj plus zk. Here r, that is indicated by the standard position vector, that is r bar equal to xi plus yj plus zk. Then r square equal to x square plus y square plus z square. Now partial derivative of r with respect to x, y and z. Then firstly with respect to r, that is 2r del r by del x equal to 2x. Here 2 which is cancel out. Then del r by del x equal to x by r. Similarly del r by del y, that is y by r. Similarly del r by del z equal to z by r. Here nibla r raised to n equal to I cap del by del x plus j cap del by del y plus k cap del by del z of r raised to n. Now r raised to n which is comes inside the bracket, then I del by del x of r raised to n plus j del by del y of r raised to n plus k del by del z of r raised to n. Here derivative of r raised to n, that is n r raised to n minus 1. Then I n r raised to n minus 1 del r by del x plus j n r raised to n minus 1 del r by del y plus k n r raised to n minus 1 del r by del z. You all are aware about the values of del r by del x, del r by del y and del r by del z. Substitute it, which is already find. Then it becomes I n r raised to n minus 1 x by r plus j n r raised to n minus 1 y by r plus k n r raised to n minus 1 z by r. In this particular equation, n r raised to n minus 1 which is common out, remaining term becomes xi plus yj plus zk. Here xi plus yj plus zk, that is our position vector, that is r bar. Then substitute it, then it will be give you n r raised to n minus 2 into r bar. Hence prove that our example. Now let's see one more example. Find the angle between the surfaces x square plus y square plus z square equal to 9 and x square plus y square minus z equal to 3 at particular point 2 minus 1 2. Here we have the two surfaces. Then we consider one is a phi 1, another one is a phi 2. Then phi 1 equal to x square plus y square plus z square minus 9 equal to 0 and phi 2 equal to x square plus y square minus z minus 3 equal to 0. First, finding the gradient of the first surfaces, the nibla f phi 1 equal to I del phi 1 by del x plus j del phi 1 by del y plus k del phi 1 by del z. Then partial derivative of phi with respect to x, y, z and substitute it, then it will give you I cap 2x plus j cap 2y plus k cap 2z. Now substituting the x equal to 2, y equal to minus 1 and 2, z equal to 2, that will give you del phi 1 at particular point, that is 2 minus 1 2, that is 4i minus 2j plus 4k. Similarly we can find the gradient for the another surfaces, that is phi 2. Then nibla phi 2 equal to I del phi 2 by del x plus j del phi 2 by del y plus k del phi 2 by del z. Here partial derivative of phi 2 with respect to x, y, z, then it will be give you I 2x plus j 2y plus k minus 1. Here substituting the values of x, y and z at particular point, then it will be give you del phi 2 at particular point, that is 4i minus 2j minus k. Let's see finding the angle between two surfaces, that is cos theta equal to, we have the formula already you learn in 11-12 science. Cos theta equal to nibla phi 1 into nibla phi 2 upon mode of nibla phi 1 into mode of nibla phi 2. Nibla phi 1, that is 4i minus 2j plus 4k into 4i minus 2j minus k. Here mode of nibla phi 1, that is square root of 4 square, that is 16, plus 4 plus 16, that is 36. Then square root of 36, that is 6. Similarly, mode of nebula phi 2, that is square root of 16 plus 4 plus 1, that is square root of 21. In numerator portion, dot product, that is 4 into 4, 16, minus 4, that is 8. That it will give you 8 by 3 root 21. Then theta equal to cos inverse 8 by 3 square root of 21. That is our angle. Let's see next topic, which is directional derivative. The rate of change of function of several variables in the direction of the coordinate axis is known as directional derivative. The directional derivative of a function f of x, y, z in the direction of a vector a bar is a component of nebula f in the direction of a bar. The directional derivative of in the direction of a bar is given by dA of f equal to nebula f of a cap. Here a cap indicated by the unit vector, or find for the formula for the unit vector, that is a bar upon mode of a bar. Let's see one example. Find the directional derivative of the function xy square plus yz square at point 2, minus 1 and 1 in the direction vector I plus 2j plus 2k. Firstly, finding the gradient, then grad f equal to I del f by del x plus j del f by del y plus k del f by del z. Then partial derivative of function with respect to x, y and z, that is I y square plus j 2xy plus z square plus k 2yz. Now substituting the x as a 2, y as a minus 1 and z as a 1 in this particular equation, that will give you nebula f equal to I minus 3j minus 2k. Now let's see to finding the unit vector. The unit vector a cap equal to a bar upon mode of a bar, and directional derivative in the direction of the vector a bar equal to I plus 2j plus 2k. Then directional derivative dA of f equal to nebula f into a cap equal to nebula f into a bar upon mode of a bar. Here nebula f, that is I minus 3j minus 2k into I plus 2j plus 2k upon square root of 1 plus 4 plus 4. Simplified that particular term, then 1 minus 6 minus 4 divided by 3, that is minus 3. This is all about the topics of the directional derivative and gradient. I hope you guys learn something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do this, share with them. If you want to watch more tutorial like this, then you can subscribe my YouTube channel, and whenever I upload the new video, you get the notification. If you have any query regarding this, then feel free contact me. Thank you so much for watching me.